Welcome to lesson 29 of industrial automation and control. Today we will start discussing pneumatic control systems, and we will discuss the pneumatic principles, the main pneumatic system components, and some simple applications. So, coming on to the instructional objectives, after learning the lesson, the students should be able to describe the principles of operation of pneumatic systems and understand its advantages, be familiar with basic pneumatic components and what roles they play in the overall system, describe the main technical features of pneumatic compressors and its accessories of course, and be familiar with direction control valves. So, that will give us the first a basic idea of a pneumatic control system. So, what is pneumatics? As I often do, I checked up the Oxford Reference Dictionary, and pneumatics means operated by air or gas under pressure. So, since we have already had some lectures on lessons on hydraulic controls, in hydraulics controls they are both hydraulics and pneumatics are fluidic control systems, where a fluid under pressure is used to do work. In hydraulics this fluid is oil, and in pneumatics it is air, it is compressed air. So, there are certain advantages and disadvantages as well of using compressed air. So, the main benefits of pneumatic systems is that air is free to collect and exhaust. So, it is simply collected, you do not need to buy it, and therefore it is cheap, and it can be exhausted into the atmosphere. So, you do not need return tubing. So, you see that for hydraulics you need one pipe or tube for carrying the fluid to the place of work, namely the load, and you need another pipe or tube to bring it back. Now, this is not necessary for pneumatics, since you are using air, which is mostly the case, because you can directly exhaust it to the atmosphere right at that place of work, and therefore you save half the tubing costs. So, that is quite a lot. There is another reason why pneumatics is generally turns out to be cheaper than electric actuation or hydraulic actuation. One of the reasons is that in pneumatics the cost of the air handling equipment, that is the compressor, basically the compressor, actually is shared among the application. So, suppose in a factory, if you go to let us say a factory like let us say Telco, if you go to the assembly plant of Telco, then you will find that there are numerous places where pieces of let us say pieces of the engine are getting assembled. So, in each one of these places there you will find that there are various kinds of tools are to be used, So, like wrenches, screwdrivers. Now, to ensure a uniform degree of performance with these tools, and also not to exhaust the operator, people use pneumatic tools. So, you will find that every operator station actually has some compressed air supply, and that compressed air supply. So, you are using compressed air to do work at numerous places, but you possibly need only one big compressor and then run a line of compressed air through at different places. So, the cost of the compressor actually gets divided, and this leads to cheaper a system compared to let us say electric, where you would have needed to maybe put a motor at each of these places, right. So, therefore, in such cases where there are numerous applications spread over some area, generally the cost of pneumatic systems become cheaper. Now, there is another important advantage of pneumatic systems is that while electric systems are prone to fire because of electric sparks and hydraulic oil is inflammable, being from petroleum derivative. Pneumatic systems are intrinsically safe and therefore often preferred in places like explosive environments. Let's say a natural gas plant would have a lot of application for pneumatic control systems to be free from the hazard of explosion. Similarly, maintenance is easier because of the fact that in hydraulic systems, if there is a leak in oil, which is a major maintenance headache, then first of all you are going to lose oil, so that is expensive. Secondly, it is going to create general environmental problem. Thirdly, it is also inflammable. But in pneumatics, if there are small leaks here and there which are kind of inevitable, then apart from the fact that a leak is always going to cause a loss of pressure and therefore some loss of energy, apart from that the consequences of that leak are minimal and therefore maintenance need not be so stringent. So, maintenance is generally a little easier. On the other hand, there are disadvantages of pneumatic systems as well. For example, firstly, these systems are slower in performance compared to hydraulics. Their power handling ratings are also generally slower, and compared to in terms of sophisticated controls, they are inferior to electric controls. So, having said that, because of these there are quite a few uses of compressed air in the industry, and some of them are pneumatic control valves. So, basically pneumatically actuated control valves, that is what I meant. So, have big valves, flow control valves which are operated pneumatically using air. Then there are air cylinders for actuation. Then sometimes you need starting air for diesel and gas turbine engines, diesel generators and gas turbine engines. For that also you need compressed air. You need tools. So, various types of tools for screw driving, for drilling, for paint spray and for clamping. So, for such operations people often use compressed air tools. So, there are lots of applications of pneumatics in the industry. So, typical pneumatic control systems block diagram wise would look like this. So, you have a source, of air or gas which is at high pressure. This source is generally coming from the compressor, and then you have a regulator, and this is actually a pressure regulator. This is a pressure regulator. After that you actually get the gas at the pressure that your equipment will require. Similarly, you can also have feedbacks, you can have pneumatic signal feedbacks using things like I2P converters, current to pressure converters. So, you can have pneumatic feedbacks, signals from various sensors, and then you can have a pneumatic control system. So, this control system will consist of various maybe direction control valves and various pneumatic logic valves, and or we will see them in the next lesson. And finally, this from the pneumatic control system and using this regulated gas supply, the actuation signal is given. In this case, the application that we have shown is a valve actuator, where this valve is actually moved using pressure on this diaphragm. So, this is a diaphragm, this is a diaphragm. So, using this pressurized gas, you actually apply pressure in this cavity. So, what will happen is that this diaphragm will, under pressure, it will come down and it will close the valve here. So, this typically is a kind of schematic that is used for pneumatic controls, and various kinds of technologies are used. So, we are going to have a look at that. So, let us look at the basic elements, the basic equipment in a pneumatic system. So, we start with the compressor. So, this is the compressor A. Then after the compressor you sometimes have a check valve B. Then you have an accumulator or reservoir of compressed air. This is very much necessary in pneumatic systems to improve response speed, as we will discuss. After that you can have various kinds of equipment. For example, in this case we have only shown a direction control valve, which is trying to drive an air cylinder. So, but this is a very typical and simple system, but in general you can have various other pieces of equipment, like you can have pressure regulators, you can have flow control valve, various kinds of valves apart from this simple direction control valve. So, you have your actual control system elements here. This up to this is generally the gas compressed air system. This is the pneumatic control system, pneumatic control elements, and then finally the actuator. So, these are the three types of equipment which are typically used in pneumatic controls. So, A compressor, B check valve, C accumulator, D direction control valve, and finally E is the actuating cylinder or actuator. Now, in system components, compressor is the pressure source. Sometimes you can have a linear air cylinder, or sometimes you can also have a pneumatic motor. Reservoir or accumulator. Reservoir accumulator is very much necessary because of the fact that pneumatic system response tends to suffer, because suppose you want to move a cylinder, then you have to create pressure on it. Now, creating pressure actually takes some time, because the air will have to flow into the cylinder chamber and then get compressed enough. So, and then the pressure inside the cylinder will build up and the cylinder will move. So, what happens is that if you want to move the cylinder quickly after let us say giving a control signal in terms of opening a direction control valve, then you want that quickly a lot of air can be supplied to the cylinder chamber, so that it's quickly the pressure builds up and the cylinder starts to move. Now, supplying this a lot of pressurized air quickly is the basic problem, because compressors are devices which can create a steady source of compressed air, but a very instant supply of large volume of air cannot be supplied from the compressor itself. So, in that situation the accumulator comes into play, and in such situation the large volume of air can directly come from the accumulator, and then the accumulator can get slowly filled up by the compressor again. So, this improves system response a lot. Therefore, in pneumatic control systems accumulators are very much necessary, more than in hydraulic controls. Then we have the direction control valves and actuator, as we have already said, and we naturally need correcting tubing and accessories like filters. There are just like in hydraulics, there are various types of control devices which are also used here. So, you have pressure control devices like pressure regulators, you have check valves which control flow, that is allows flow in a certain direction and does not allow flow in the other direction. Then there are flow control valves. Flow control valves in this case they are not they are mainly used to control the speed of motion. So, sometimes you need that for example, in the case of hydraulics we have seen that when you are driving the load, typically you need slow motion, and when you are returning without load you can have fast motion to save time. So, in such cases flow control valves are used much very similarly as to what you use in hydraulics. Then there are various kinds of, if you have feedback control, then you can have various kinds of feedback elements like pressure switches, you can have push buttons for operator commands, and of course you have various kinds of electrical interface devices like you have I to P converters. So, for interfacing between electrical systems and hydraulic systems. Seam balls are very similar to the ones we used in hydraulics. So, compressor is like this, only note that the triangle is hollow. In the case of hydraulics, the triangle was solid because it was oil. Then you have reservoir, you have filter, motor, hydraulic motor, the same as electric motor, or rather this is pneumatic motor. Then direction control valve, pressure switch, and pressure gauge. Pressure gauges are used at various points in pneumatics to either to feed back pressure values or to read them, and of course the cylinders. So, these symbols are fairly common and very similar to hydraulics. Then we look at compressors. Compressors are the machines which are designed to compress gases from an inlet pressure which is generally atmospheric. So, it takes air from the atmosphere, filters it, and then compresses it to a high pressure. And there are this mechanism can be of generally of two types. One is positive displacement, where each time a certain given volume of air is converted from the atmospheric pressure to high pressure. So, every cycle of movement of the compressor, whether it is rotational or translational, converts a certain amount of gas from low pressure to high pressure. Then when you and the other kind is non-positive displacement, which is basically centrifugal type, basically fans, essentially types of fans and blowers, which are typically used when you need large volumes of air, but not at such high pressure. So, typically for high pressures positive displacement type compressors are used. If you want to convert to a very high pressure, something like 600, 700, 800, 1000 psi, then you often need to do it in multiple stages. So, a compressor can have various stages, single or multiple, and it needs to be driven, right. So, because it compresses the air, so therefore, it needs to be driven by a prime mover, and that there are various types of prime movers possible. It can be the prime mover can be an electric motor, or it can be an IC engine or it can be even sometimes it can be a something like a turbine with which this the compressor will be coupled. So, in places where you have such turbines, then you can actually use that energy for running the compressor. So, positive displacement could involve linear motion or could involve circular motion. So, you can have either reciprocating piston type, or you can have rotating vane types or rotary impeller. So, either you have rotational designs or you have translational designs, but in each case one cycle of rotation or one cycle of to and fro motion will take a certain given volume of air and take it to the low pressure inlet port and push it into the outlet port. So, in the reciprocating piston type, you have a piston, you have cylinder, and you have some valves, right, and there are two strokes. So, one stroke is called suction and the other stroke is called compression. So, in the suction stroke you are taking in air from the low pressure side, which is typically atmospheric, and in the compression stroke that volume of air you are pushing onto a high pressure port, and this sucking and compressing is actually guided by the set of valves, as we will see. This can also be single or multiple stages. So, here is a diagram. So, typically see this is the low pressure inlet port and this is the high pressure outlet port. So, and these are the two valves which actually control the motion, and this is coupled to the prime mover. So, maybe it is a cam operated mechanism. So, in the in the suction stroke, this cylinder moves this way as shown here, and then this valve is going to open because the pressure here is going to fall. So, this valve will open and air will flow in from the inlet. On the other hand, this is not exactly I mean this is only schematically shown. So, since this is suction, so therefore, this will seal this outlet. So, no air will be sucked from the outlet, right. Now, after this has come to the lowest position, a certain given volume of air is going to be residing inside, and that is at the low inlet pressure. After that, this alternating motion, this cylinder will start going up. The moment it starts going up, it creates a high pressure here, it actually compresses the air here. So, what happens is that this valve is now pressed up, so it will be closed, while this valve will also go up, and then that will open the actually open the so the air will flow out. So, the air will flow out during that time through this path, and this is what is happening. So, every stroke it is sucking a given volume of air from the low pressure atmospheric side, and it is pushing the air back into the high pressure outlet. So, this is a reciprocating type compressor mechanism. For rotary compressors, they are either vane type, where as we have seen in the case of hydraulics also we have seen vane type pumps, where the rotational motion of the vane inside a cavity will just when the vanes move, air is sucked in from the inlet and that air is transferred back to the outlet at high pressure.